Good day, dear learners. I welcome you in this new lecture in which we'll be talking about acid rain and ozone layer depletion. What are the causes and its effects on human beings, on plant community, and on animal community. So far we talked about climate change, we talked about global warming, we talked about different types of pollution that was taking place in air, water, and land. So in continuation with this, now this is something that you are quite familiar with, but we'll be talking a bit more on acid rain, on ozone layer depletion. And especially in this content, you will also find real life examples how these acid rains and ozone layer depletion, they're impacting our ecosystem and also the human health. So let's first begin. If somebody asks you, what is acid rain? So acid is a type of precipitation. So remember, it's not only in the form of rain. It can be in the form of snow. It can be in the form of fog, sleet, hailstone, you name it. Because what actually is happening is that the pollutant, remember in the air pollution, I talked about the pollutants that are released in the atmosphere in the form of sulfur dioxide and nitrogen oxides. They are basically coming down in the form of in rain, snow, and fog, because the water vapor present in the atmosphere, it combines with it. It comes down, there's a chemical reaction that is taking place, and it is creating acid. Now, acid rain is made up of, you can say, the pollutant plus the water droplets, which are already present in the atmosphere. So the two type of depositions could be the wet deposition, which we are very familiar with, that is in the form of acidic rain, fog, and snow. If acid chemicals in the air are blown into those areas, so of course we find that the acid, it falls on the ground, it can fall on human beings, on the agriculture field, on our infrastructures, and it can destroy those particular structures as well. So these are wet deposition in the form of basically acid rain, fog and snow, because snow also melts. But dry deposition is in the form of dry, you can say, dust or smoke, which falls to the ground through dry depositions, and it sticks to the ground basically. It sticks on the surface of our cars, of our, we can say, building homes, and on trees. We can find these gaseous and these particulate matter that contains the acid, and that can be washed from the surface by rainstorms, which ultimately leads to increased runoff. Now, what actually happens is, now this is the image, you can see the formation of calcium sulfate, which results in the corrosion of these beautiful monuments. So, of course, anything that you're building up, and if it is acid, is something that will definitely harm them. It will destroy its physical property, its chemical property as well, and it will cause discoloration. All the physical phenomena, you'll be able to observe it. So we find that those oxides of sulfur and nitrogen, if they combine with water and oxygen in the atmosphere, it comes down as sulfuric acid, nitric acid, respectively. Right? Now, the typical pH factors, pH means the potential of hydrogen, that is actually helps us to calculate the acidity and the basicity. So pH of acid rain is around 4.2 to 4.4, which makes it more acidic than the normal rain. Normal rain is also acidic, which is around 5.6, because you cannot avoid it, because CO2 is present and water vapor are there. So carbonic acid will be formed. But if it is increasing, the amount of gases, the oxide of sulfur and nitrogen are increases, and if it combines with water and comes down, so definitely the pH will reduce, and the more it reduces, the more acidity it will become. So the causes of acid rain is a form of the natural causes we'll be looking into, and also we'll be looking into the anthropogenic causes. So first, let's have a look at the natural causes. The first thing that all the natural calamities comes in our mind when we talk about natural causes, right? So the volcanic eruptions, because it releases sulfur dioxide right in the atmosphere where already water vapor is present. So of course, sulfuric acid will be formed. Then sea spray. Sea spray, they do not cause acid rain directly, but because of the spray, the aerosols, the salt droplets, they're highly reactive. And once they combine with the gaseous matter pollutant in the atmosphere and the water vapor, then they undergo a rapid chemical aging process and they come down and they lower the pH of the rainwater. Then even lightning, you'll be so surprised to know, it produces nitrogen oxides and sulfur dioxide which contribute to acid. Then wildfires, because wildfires are basically anything that you burn will release CO2 and CO if it's an incomplete combustion, and methane. All that will combine with the water and will result into acid rain. Anthropogenic causes, of course, how human activities are releasing these gases into the atmosphere. The industrial emissions, the burning of the fuels, the vehicle exhaust, even the electricity generation, because it is taking place through coal-based power stations. So coal, you're burning fossil fuel and releasing these oxides right into the atmosphere. Then burning of waste and biomass, they also release harmful gases which contribute to acid rain. Now, effect of acid rain. Now, the acid rain, it damages the forest, the plants, and the community as well, plant and animal community. It also degrades the soil quality. Because just imagine if you're pouring acid onto the soil, what will happen to the fertility of the soil? What will happen to the major nutrients that are present in the soil? The calcium, magnesium, all the things that are there, they will start reacting because of the acid and make the soil less fertile or devoid of its fertility. And of course, it harms the aquatic life as well, because if the lower the pH, the more acidic the water body is. And just like I said in my last lecture, remember I talked about how the shellfish and the different skeletons of the marine ecosystem, marine organisms, they have calcium carbonate. So it reacts with the acid. And they can kill and become, it is highly fatal for the fish, the amphibians and aquatic organisms. Then it is also damaging to the building and monuments. The stones, the marbles that cause corrosions and damage to the buildings and the statues and historical monuments. We can see the discoloration, the rusting process, the corrosion that is taking place. And human health effect. Now, can you imagine acid falling on your skin? What will happen to your skin? What will happen to your hair? And, and the same water, the acidic water, if you're drinking it, what will happen to our digestive system, our respiratory system? So you can see different respiratory problems like asthma, bronchitis, that also becomes because of acid rain. Then reduced crop productivity. The plants, they cannot bear acid being poured on them. The soil fertility is in itself being destroyed because of acid rain, and the acid, if it falls directly on the plant, can imagine what will happen to the plant surface, the trees, the leaves, what will happen to the stomatas, what will be the growth of those plants, they will stop flowering and they'll reduce the agricultural yield. So that was all about acid rain. Now coming to another key concept that we're going to study today is ozone layer depletion. But for that, we should understand some key terms. First, what is ozone? Now, ozone is a form of oxygen which is made up of 3 oxygen atoms, O3. So, unlike normal oxygen is O2, you add 1 to it, it becomes ozone O3. And it is a natural occurring gas present in you'll be so surprised, it's present in very small amount in the Earth atmosphere. So, the ozone gas is pale bluish gas with a very sharp and pungent smell, and it is highly reactive. And see how amazing this gas is, that Almighty has created ozone gas and has placed it in the top the layer above the troposphere, that is stratosphere. It has placed the ozone layer there. Had the ozone layer being present at the ground level, at the troposphere, and it was the layer was compressed in the troposphere level, so it will be a few millimeters. It is the thickness, and this ozone gas is highly poisonous. It will kill the living organism here. But see where the Almighty has placed the ozone layer and ozone gas right in the stratosphere, because it is protecting us. So the gas, that is the ozone gas, which is present in the stratosphere, forms the ozone layer. And it is helping in absorbing the ultraviolet rays, filtering the ultraviolet rays. So it doesn't directly enter our troposphere and comes direct contact with human beings, animals, and plants, because ultimately it is helping us in preventing different kind of eye damages and different kind of disease and cancerous diseases of skin and harm to plants and animals. So if asked where is the ozone found in the atmosphere, so most of the ozone, 90% of the ozone, is found in the stratosphere, and you can see it begins between 8 to 18 kilometers, the layer of the ozone, right? Now, ozone in this region is commonly known as the ozone layer, and of course, it is helping the ultraviolet rays that are penetrating, that are coming, they're falling on the Earth's surface. It breaks. Surprisingly, you will be so surprised to know that ultraviolet rays has another job. What it is doing. It is breaking the O2 into O atoms, breaking it O2. So the singular O will combine with O2 to form O3. So this whole chain reaction is taking place. O3 getting converted into O2 and O2 getting converted into O3. All that is taking place in that particular layer, that ozone layer. Now there's another term, ozone depletion. If it is so important to us, what is happening to it? Why is it getting depleted? And what do you mean by ozone hole? Where is that hole? Is it really, in a literal meaning, is it a hole? Or is the thickness decreasing so it looks like a whole structure, a whole, there's a, like a void in that particular layer. So you have to understand, like I said, about ultraviolet rays and infrareds, how they are invisible electromagnetic radiation located at opposite end of the visible light spectrum. And the primary difference is the ultraviolet rays are shorter wavelength with higher energy, and infrared are longer wavelength with lower energy. And what it is doing, the ozone layer, it is helping in preventing the UV rays to come directly in contact with us. But because, or unfortunately because of the air pollution, this layer, the chemicals that we are releasing, the gases that we are releasing, and the chlorofluorocarbons that later on we will be able to understand how they are basically causing the harm, and they're reacting with O2. It's breaking O3 into O2 and O. So definitely when the O3 concentration is reducing in the stratosphere, we find that the hole is increasing, and directly the ultraviolet rays are coming inside and they're harming the atmosphere. Right? Now, where are these chemicals coming from, and what are responsible for the ozone hole? So the first main culprits of ozone layer depletion are the chlorofluorocarbons. And these CFCs 11, CFC 12, freons, they are non-reactive, they're odorless, non-flammable, non-toxic, and non-corrosive. But they're widely used in air-conditioned refrigerator and some sprays. Now, these CFCs, you have to understand that they stay a longer period in stratosphere, more than 50 years. Imagine that. And during this period, each chlorine atom is capable of converting 105 molecules of ozone into O2. Now you see, one chlorine atom is doing this job. So when the O3 concentration is reducing and O2 concentration is increasing. So you see, this is exactly what is happening. The reverse is not taking place because of chlorine that is present, and if it is surviving there for more than 50 years, so you can imagine the devastating effect it is happening in the ozone layer. So this is how basically it is causing the thinning of the layer and ultimately leading to an ozone hole. Now here you see a table in which we have ozone depleting substances and what are the sources, where are they generating from, which human activities is basically responsible for generating it. So we have chlorofluorocarbons from refrigerator, halogens from fire extinguishers, carbon tetrachloride also from fire extinguishers and solvents, methyl chloroform, adhesive, aerosols, hydrofluorocarbons also mentioned in air conditions, in solvents and fire extinguishers. Now the causes of ozone depletion. Now if you look at the causes, first cause is the chlorofluorocarbons coming from different sources. From different anthropogenic sources, we are releasing the chlorine atom which reacts with ozones and destroys it. Second is unregulated rocket launches. Because the rocket which is being launched, it releases gases such as chlorine compounds and nitrogen oxides directly into the atmosphere. So you can imagine, right at the source, you're releasing those oxides. So definitely they're reacting with the ozone and they're contributing in the thinning of the ozone layer. Then global warming directly affects the ozone layer. So the more greenhouse gases are being released there, the Earth's atmosphere temperatures is increasing, and which also enhance ozone depletion, especially in the polar region. Then nitrogen compounds are also released from the different fertilizers we are using. And because of the fertilizers, it releases nitrous oxide into the atmosphere. And as this gases rises to the stratosphere, it reacts with the ozone. So some way or the other, our activities are releasing this oxide right into the atmosphere, which travels to the stratosphere and it combines with them. The nuclear test, another reason we find, because it is releasing large amount of nitrogen oxides and other reactive gases into the atmosphere. And these gases, they destroy the ozone molecules and weakens and thins the ozone layer. So what is the effect? What will happen to us? When the layer becomes thin, or a hole-like structure is appearing in that layer, ultraviolet rays are coming directly. Now there's nothing protecting, no barrier is in between. So the UV rays that are coming, if you look into it, it damages the eye cornea. It leads to diseases like cataract and even blindness. And 1% decrease in ozone can increase the cataract risk by 0.3 to 0.6%. Then even on your skin, if the more you're exposed to ultraviolet, it causes sunburn, skin cancer like melanoma, which is serious, and non-melanoma, which is a common type. So ultraviolet rays can also alter the biochem molecules, which are linked with diseases like breast cancers and leukemia as well. So sometimes it really becomes fatal also when we're directly exposed to ultraviolet rays. Then effect on human immunity. Our immune system is also suppressed. And basically, immune system is helping to fight against infection and diseases. So if your immune system is affected, so it affects the skin cells, immune systems, and of course, when ultimately it will lead to many different diseases as well, because your immune system is no longer working properly. Then there's a DNA damage also. How ultraviolet B radiation damages DNA and other molecules, which leads to mutations and skin cancer as well. It affects the lungs also, causing diseases such as bronchitis, asthma, and emphysema. Now, you can say the effect is we feel that it is on the food shortage as well. How the ozone depletion, when it increases ultraviolet radiation, it reduces the crop productivity as well. So you face food shortages as humans heavily depend on crops. So there are studies which suggest that ultraviolet rays may improve yield only when they are used with phyto hormones. Then effect on animals, just like if human beings are affected, plant community is affected. So it's needless to say animals will also be affected. Then effect on the environment, how the ultraviolet rays also affects the flowering season, the photosynthesis of the plants, and the forest also have to bear the harmful effect of the ultraviolet rays. Then coming to the effect on marine life. Even the planktons are greatly affected by the exposure to the ultraviolet rays. They're very sensitive. So if there is any change in the pH factor, if it becomes acidic, too much CO2, or exposure to ultraviolet rays, it will disrupt the food chain. And if the phytoplanktons die, the other aquatic organisms which are in the food chain will also be affected. Now coming to the last part of the policies and agreements related to ozone depletion. So first we have the Montreal Protocol, which was adopted in 1987, and it aims to phase out in a phase out manner. It wants to deplete the ozone depleting substances like CFCs and halogens. Then we have Vienna Convention for the protection of ozone layer, which was previous to the Montreal Protocol, and this was a framework for international cooperation on ozone protection. So it encourages the countries to take up the preventive measures laid down by Vienna Conventions, and Montreal Protocols. Then we have Kigali Amendment, which was also adopted in 2016. It aims to reduce hydrofluorocarbons, which are harmful greenhouse gases. And although HFCs do not deplete ozone, remember that CFCs do, but HFCs do not deplete. Indirectly, they're contributing to what? Global warming. So the amendment, it sets targets for the countries to gradually reduce HFC use, and it supports climate protection along with ozone recovery. Then ozone depleting substances regulation and control rules, which was introduced in India in 2000. So basically, this is also follows the guidelines of Montreal Protocol. The rule bans or restricts harmful chemicals like CFCs in industries. So it's helping India contribute to the global ozone layer protection as well. So to conclude, what have we seen so far? We have seen that acid rain and ozone depletions are the significant environmental challenges that result primarily from anthropogenic activities and which have very far-reaching consequences not only on human health but on ecosystem and on our biodiversity, on our agriculture produce and so on. While acid rain, it degrades forest, soils, aquatic ecosystem, the ozone layer depletion increases the exposure to harmful ultraviolet rays, and it also poses a serious risk to the living organisms. But however, these problems can be effectively addressed and can be curtailed through sustainable practices, cleaner technology, and of course, we have to reduce the emission. And the emission can be only reduced if we put some restriction on our anthropogenic activities. And of course, with the help of the international cooperation, we are able to put some ban, some limit to our greenhouse gas emissions also, and on the CFCs and HFCs emissions as well. So protecting the environment requires a collective responsibility and informed actions. So by adopting environmentally responsible behaviors today, we can safeguard the planet and ensure that it is healthy, it is safer and more sustainable for our future generations to come. So with this, I have come to the end of today's lecture on acid rain and ozone layer depletion, and I hope the concept is now very clear to you. These are the references. If you want to have a detailed reading on acid rain and ozone layer depletion, you can go ahead, click on this link. Thank you so much for your patience listening, and I'll be meeting you again with another new topic. So till then, take care of yourself and have a good day. Thank you.